So now what we have to do is we have to work on the gradient, or the uncertainty in the gradient. And this is slightly different from in high school. In high school they used to say when you did a graph like this, they'd say draw a line of best fit and then draw a second line of error. But actually now we can do more serious stuff. What we actually do is we draw two lines of best fit, both of which are reasonable. And that's a good question. What do you define as reasonable? Because I might define that as a good line. So I might draw a line in for that one. I'll just give that one a red line. I'm going to use the second and fourth points. And I might also define that as a line of good fit. So actually let's use a blue one for that. So now I've got two lines of good fit. I've got a red one and a blue one. So how do I work? Well, I work out M exactly the same way. Let's do the red one first. M is equal to y2 minus y1 over x2 minus x1. Okay, I have chosen this point and I have chosen, it's meant to be that point. Okay, it's second and the fourth, so this is going to be 30, 3.9, 20, 3.2, sorry, 23.2. And this point here is 40, 5.1, 40, 5.1. That's my point. That's 1, that's 2. For the blue ones, my points are the third one, 30, 3.9, and 67. It's going to be, for the red, it's going to be 0.1 and 0.2. So let's work the red one. So y2 is 5.1 minus 3.2 over 40 minus 20. That means M1 is equal to, what's that, 2.1 divided by 20, 2.1 divided by 20 is equal to 0.105 meters per second. We then work out M2. M2 is equal to a change in y over change in x. Y1 over x2 minus x1, which is equal to 7 minus 3.9 over 60 minus 30. What's that equal to? 3.1 divided by 30 equals 0.1033 meters per second. Now to find M is equal to the average M1 plus M2 over 2. That sounds cool. So basically what we do is we go M1 plus M2. M1 is 0.105 plus 1.033 meters per second over 2 equals plus 0.105 divided by 2 equals 0.1042 meters per second. Now the uncertainty, sigma m, the uncertainty is going to equal m, the magnitude. What that means is if we end up with a negative number, turn it into a positive number, of m1 minus m2 over divided by 4, and that's going to give us the standard uncertainty. So in this case the uncertainty is going to be m1 0.105 minus 0.1033 second, take the magnitude, over 4, which is equal to 0.105 minus 0.1033. As I said, don't worry about if it's a negative number. Divide by 4. So it's going to equal 0.0000425. So when we're writing the final answer, m, we take the average, 0.1042, plus or minus, remember we only give the uncertainty to one significant figure, 0.000, round that off to 4. So in this case, the gradient, that's all going to be measured in meters per second. So the gradient on that is 0.1042 plus or minus 0.0004 meters per second.